Good morning, good afternoon, good evening. Welcome to this video on the nature of roots. Um, this is that section in mathematics that is literally standing between someone getting that A that they need in mathematics and them getting that 75 or 76. So if you really are good in this section, that will propel you into that A. Usually these types of questions that you get are the level 3 types questions that come from this section. So before we go into how do we solve these, let's first discuss the theory around it. One thing we need to understand is the number system, right? So you would have done the number system in grade 8, grade 9, grade 10, and I think in grade 11 as well. You guys do a little bit of number system. And what that is, it's the three categories that numbers can be put under, right? There's this first category, which is the undefined category. And in that category, these are all the numbers that are undefined, but we need a definition for it. And that definition says anything divided by zero. So anything divided by zero is undefined. It's what we define as undefined. So if you take anything, any number, it does not matter how the number looks like, and you divide it by zero, you will always get an undefined answer, right? So yeah, that is the first category. Then the second category here is called the non-real category, also known as the imaginary category. And for this one, what we need is, as soon as you get a square root, right? A square root of a negative number, that will give you a non-real answer. So how does that look like? Square root of a negative 3, square root of a negative 5, square root of a negative 25. All of these are examples of something that is imaginary, so something that is non-real. Then ultimately we end up with this section right here, of which we work a lot under the section. And in real numbers, it's basically everything that is not non-real and everything that is not undefined. So here we get different sections, right? We have a rational number, and a rational number quite easily could be defined as a number that can be represented as a over b. So whenever I get an integer that is dividing another integer, then I get what we call as a rational number. So that's what we call a rational number, right? And rational is a type of a real number. Then under there's other types of numbers that fall under there. And for interest's sake, this that I'm going to write under here, which is irrational, is the opposite of rational. So that is something that cannot be written as a over b. So they cannot be represented as fractions, and these include your mathematical symbols that you know, pi. There is the golden ratio there as well. There is e, and any square root of a non-perfect square will also be what we call irrational. So yeah, I think by the level at which you studied it at, maybe grade 9 or grade 10, you would have thought, oh, there's less irrational numbers than there are rational numbers. Actually, no, there are infinite amount of irrational numbers. Because as much as you can imagine, these non-perfect squares, and these non-perfect squares, what numbers are those? Those are roots of, for example, if I take a root of a 5, this does not give me a proper number. Instead, it gives me a decimal number with infinite decimal points. There, these decimal points are non-terminating; they do not end, and those decimal points are non-recurring as well. So as long as they do not end and they do not repeat each other, then we know this as an irrational number. So you can think about infinite numbers that when you put underneath the root, you don't get a perfect whole number coming out. And those, again, we know them as irrational numbers. So under rational, there are different types of rational numbers, obviously. There's integers, there's natural numbers, and there's whole numbers. We won't go under that section because, again, it's not really important for this sake. But what is very important is to know the difference between a rational number and an irrational number. And to understand that one is the square root of a non-perfect square, obviously with those symbols there. Pi is also an irrational number, the golden ratio, and E. And the other irrational number is if I can divide two integers together, I always end up with a rational number, right? And these are just examples of those. And another thing you need to really understand is that imaginary numbers is if you're square rooting a negative number. And then lastly, undefined numbers as if these numbers where you're taking anything and you're dividing it by 0. So now that we know these three different types of big sections in math in terms of where numbers can be classified, what is the relevance when it comes to the nature of roots? So one thing you should remember is that a quadratic equation, ax squared plus bx plus c is equal to 0. This quadratic equation, once I solve for x, I always solve for x and I get 2x values, right? I could use my quadratic formula to help me solve for x. I could factorize that to help me solve for x. Or I could also use completing a square to actually help me solve for the x. So these guys that I get here as the x values, of which graphically those are my x-intercept of that parabola. So if I have a parabola, those x value, one would be there and the other one would be there. These guys are also called roots. So yes, when we were solving these quadratic equations, we knew them as answers, but right now we're just changing the way we view them. These guys are called roots. These are the roots to the equation, right? So what we are interested in when it comes to nature of roots is what are these roots? What do they look like? So we could, one or the other, we could either solve these equations and actually see what those roots are, the numbers that come out of there, but we're not interested in actually solving or factorizing or actually finding the answers. We want to be able to speak about the roots without actually solving it. And for that, we need an instrument. We need something to help us. So one thing we remember is this guy here, which is our quadratic formula. So we're using that quadratic formula, not just the whole quadratic formula, but instead this guy right underneath the root, of which we're going to call the discriminant. That guy, the discriminant, right, which is delta, we also going to call it delta, is b squared minus 4ac. So just looking at that guy and solving what this guy is will tell us what types of roots we are getting. So for example, if that root was a negative number, so if whatever answer it was, it came out as a -5, then it would tell me straight up that, ooh, these are non-real roots. Why? Because a non-real number is if you are taking a square root of a negative number, right? So if it comes out as a negative, it tells me it's non-real. If it comes out as a positive, it tells me that it's real. If it comes out as certain numbers, it tells me that it's rational. And if it comes out as certain numbers, it tells me that it's irrational. Right? So we don't actually need to solve the equation. We could just look at the discriminant and work with the discriminant, and the discriminant will tell me what types of roots I'll be getting. So it tells me what types of roots. It does not actually tell me the actual numbers of those roots. It just tells me the type that those roots have. So now let's come up with a with like a criteria that's going to help us to know which roots are this and which roots are that. So these are the three categories of the types of roots we're interested in, right? So the first one is if it's real or non-real. Those are the types of roots we're interested in. We're asking the question, are they real or are they non-real? So for them to be real, the discriminant should be greater than or equal to 0. Again, we talked about it. If it is a negative, that's when it's non-real. So when is it real is if it's positive or greater or equal to 0. So this is when the roots are real. Then if that discriminant, that b squared minus ac guy, comes out as a negative, then that tells me these are non-real roots. Right? Then another category that we're interested in is if they're real or non-real, but if they're rational or irrational. Rational or irrational. So that's the other question we're very interested in. We're asking, are these roots rational or irrational, right? So how do we determine that? First of all, for a root to be rational or irrational, this criteria needs to be met. It has to be real. For it to be either rational actually has a AL. For it to be a rational, it has to be real, because rational and irrational numbers are already real numbers. So again, I repeat, it has to meet this criteria here. They have to be greater or equal to 0. And so how do we know if they're rational? So if that discriminant is a perfect square, if it's equal to a perfect square, then this tells me that these roots are rational. So obviously a perfect square would be a number that is greater than 0. If that discriminant is equal to a non-perfect square, then this tells me that the roots that are coming out will be irrational. Again, you don't get a non-real rational number. Now, as soon as it says non-real, it means it does not fit under these two categories, right? So these two categories, we're only going to be checking if this number one criteria is met, the fact that they are real, right? Then one last thing that we're going to be checking, or rather asking, is if these roots are equal or non-equal. Equal or non-equal roots. Non-equal roots, right? So again, for them to be equal or non-equal roots, they need to be satisfying the first criteria, which is real. And then under these, they could be one or the other. It doesn't matter. You get rational equal roots. Wait. Actually, for it to be equal, this discriminant has to be equal to 0. So if the discriminant is equal to 0, we know that the roots are equal. But if the discriminant is not equal to 0, so if it's just equal to any number greater than 0, then we know that the roots are unequal. So what does that mean? Sometimes you do get unequal rational roots and unequal irrational roots, but you can never get equal roots that are either rational or irrational. So take note of that. The fact that it's equal to 0 tells me that it can never be a perfect square, right? The fact that it's equal to 0 tells me it can never be a non-perfect square. So for it to be equal, it actually just means it's just real, right? But it's neither rational nor irrational. You kind of do get like if it's 0, then yeah, we do assume that it is in fact rational, right? So yeah, these are the three categories that we're going to be focusing on. So if the discriminant is greater than 0, we know it's real, greater or equal to 0. If it's less than 0, we know that it's non-real. If the discriminant is a perfect square, and what do I mean by a perfect square? For example, if I take a square root of 25, I get a 5. So the 25 is called a perfect square. If I take a square root of 36, I get a 6. Again, the 36 is also called a perfect square. But if I take a square root of 17, I don't get a normal whole number coming out there, but instead I get a decimal number that has a lot of decimals there, so that we call a non-perfect square. So I hope you're seeing the difference between each of these. All right, so now I've been talking a lot about which categories we're going to be looking at. Let's now look at different types of examples for us to actually see what these roots are. We're going to start very easy and then we're going to slowly ramp it up. So yeah, let's start with example 1. Alrighty, so for example 1, we're given this quadratic equation is equal to 0, and we are asked to find the nature of these roots. So again, they want us to tell them if it's real or non-real, if it's rational or irrational, or if it's equal or non-equal, right? So what we do is we find our discriminant first, which is b squared minus 4ac. Let's find what those discriminant is. Remember, this is my a value, that's my b value, and that's my c value. So a is equal to 1, b is equal to -1, and c is equal to -6. So if I substitute, -1 goes there, +1 for a, and -6 for b. And if you plug this whole thing into your calculator, it will give you, it's equal to 25. And so the discriminant is actually a 25. So if it's a 25, what does this tell me? A 25 is a perfect square. So already I can tell that it's a rational, right? But like I said, you cannot have a non-real rational number. There's no such thing. So this already tells me that this is real. And what do I know? How do I know if it's real? Because the discriminant is greater or equal to 0. It's in that range. How do I know it's a rational? Because the discriminant is equal to a perfect square. Right? 25 is a perfect square. And how do I know if it's equal or non-equal? Well, this will be a non-equal, because the only one that is equal is the one that is equal to 0. So if the discriminant is equal to 0, that will be the equal ones. But if it's not equal to 0, then so the fact that it's not equal to 0 tells me that this is non-equal roots. So there we go. We spoke about them being real, we spoke about them being rational, and we spoke about them being non-real. Let's look at example 2. So we're given this example 2. Again, we need to find what my discriminant is, which is b squared minus 4ac. What is my a? My a is a 2, my b is a -5, my c is a +1. So those are the values I substitute there. -5 for b squared, sorry, that's minus 4, the a is a 2, and the c is a positive 1. And if I plug this whole thing into my calculator, I'm coming out with 17. The discriminant is equal to 17. So what does that tell me? So first of all, the fact that it's a positive number, right, tells me that this is a real. And again, how do I know? Discriminant is greater than or equal to 0. That's real. Then is it rational or irrational? That is not a perfect square, so it tells me that these are irrational roots. Right? How? Because discriminant is not equal to a perfect square, or rather it's equal to a non-perfect square. And then what else? The fact that it's irrational, it has to mean that these are unequal. So sorry, unequal is spelled like that. So how do I know that they're unequal? Because the discriminant is not equal to 0. If it was equal to 0, it would tell me that these roots are actually equal. So yeah, this is basically how you go about solving these, but these could get a little bit hard. And let's look at example 3 to look at how what we would do if they were slightly different. All right, so we're given this next question, and again, remember, we are not solving the equation, but instead here we do need to expand it a little bit just so it looks like the form we're used to, which is ax squared plus bx plus c, so we can figure out what our a is and our b and our c, right? So let's expand that. X times x, x squared minus x plus 2x minus 2. Actually, let me just bring the 4 over. Minus 4x is equal to 0. Right, I just brought the 4 over. Like terms, x squared, this, that, and that would give me a negative 3x minus 2 is equal to 0. And then here I can clearly see that my a is 1, my b is negative 3, and my c is negative 2. And now that I have that, I could just easily find my discriminant. You need to remember this formula of your discriminant. It is in your quadratic formula as well, so you don't really need to cram it, but yeah. So what is my b? My b is the negative 3 squared minus 4. The a is a 1, the c is a negative 2. And if you plug this whole thing into your calculator, this part gives me a 9, this part gives me a positive 8, and if you add them you get a 17 again. So my discriminant is equal to 17. Let me just double check. This is a 9. Negative times a negative is a positive 8. Yeah. So yeah, this is clearly the answer. And so what does this tell me? It tells me these are real. Again, why? Because the discriminant is greater than or equal to 0. It tells me that it's irrational. Why? Because again, the discriminant is not equal to a perfect square. So I keep putting these justifications under here. This is for your benefit in the test day exams. You just need to say real, irrational, and tell me that it's unequal. Again, how do I know it's unequal? Because the discriminant is not equal to 0. And there we go. So this is how you do this example. Let's look at another example that's slightly more difficult to this. Alrighty, so for example 4, we're given this equation there. Again, we're asked to discuss the nature of roots. So the first thing we need to do is bring that guy over so that it looks like standard form. And I'm going to put him first there because he has the x. Remember, the middle term is the one that has the x. And the last term will look like that. So here we have p's and instead of numbers. But that should not deter us. Remember, the only way to discuss the nature of roots is to solve for that discriminant. So our a will be 1. our b will be the negative 2p. This whole guy here, the coefficient of x, and our c would be the p squared. So my discriminant would be b squared minus 4ac. Substitute the b, substitute the a, and substitute the c. Then if you multiply this out, if you square the first guy, you get a positive 4p squared. If you multiply those guys, you also get a negative 4p squared. Actually, these subtract and give you 0. So what is that telling me? My discriminant is 0. So I might not know what the value of p is, but I can still discuss what the roots would look like. So the fact that it's a 0 tells me that they're real, because again, real is always greater than or equal to 0. It tells me that these roots are rational. So if it's equal to 0, it's rational. 0 is a perfect square. If you square root of 0, you end up with a 0. So the fact that it's 0 tells me this guy is a perfect square. So it has to be rational. And lastly, these roots are going to be equal. Because remember, equal roots are the ones that are equal to 0. So there we go. I've discussed the roots. And even though I can't actually solve this equation because I don't know what p is, unless p is given, then I can. But since I don't know what p is, I can still discuss the fact that those roots are real, that they're rational, and that they're equal. And this means for any value of p, no matter what you substitute for p, these are always going to be the roots that come out of that equation. Hope that makes sense. Let's do maybe one more of these type of equations, and then we'll move on to the next part. Alright, so this question is also asking us to discuss the nature of roots. So if it just says discuss, you have to actually solve for the discriminant and see what value that discriminant is equal to. Even if they put k's in there, you just trust that at some point the k's are going to cancel and you will get just your discriminant equal to a number. So in this case, let's just bring everything onto one side. I have my kx squared. I have this guy here. I'm not going to multiply that x in. And the reason why I'm not is because that guy would be my b. So if I multiply it in, it'll be hard for me to see what that b is. So instead I won't. But I will bring this guy over. And this guy right here would be my c, the guy that does not have an x. So what is my a? My a is k. My b is a 4k minus 1. And my c is a negative 2 plus 4k. You don't need to do anything to that. You just use them like that. So my discriminant is equal to b squared minus 4ac. I'm going to substitute. My b is a 4k minus 1 squared minus a 4. My a is a k. And my c is a negative 2 plus 4k. Right? Then I just need to multiply that through. With this, I know the quick method of doing that. You just square the first guy. You square the second guy, which is a 1. And then you times them together, and then you times them by 2. And you get a negative 8k. That's just me expanding this bracket. I still need to do the second bracket. So for this one, the k and the 4 are going to multiply first, giving me that. And that negative 4k is now going to distribute into the second bracket, giving me a positive 8k when it multiplies with a negative 2, giving me a negative 16k squared when it multiplies with that guy. So now I have this expression here, which is equal to my discriminant. What I notice is that this subtracts with that guy, they cancel. This cancels with that guy. And so actually my discriminant is equal to 1. So what does that tell me? It tells me that these roots are real. because discriminant is greater than or equal to 0. It tells me that these roots are rational, because again 1 is a perfect square. You can square root 1, you go back to 1, so this is a perfect square. And lastly, it tells me that these roots are non-equal or unequal. So remember, the only ones that are equal is when this guy is equal to 0. So the fact that it's not equal to 0 tells me that those roots are unequal. So there we go. We've discussed it, talked about whether they're real, talked about whether they're rational or irrational, and talked about whether they're equal or unequal. So there we go. This first part of this video was just me discussing the roots. So the next part, we're going to be told what type of roots that they are, and we just need to show it, or rather find the values of that variable that are going to give me those roots. So let's look at examples that look like that. All right, for this next part, the question reads, find the values of m for which the roots are going to be number A, or question A, unequal real roots, question B, equal real roots, and question C, non-real roots. So before we solve for those ones, we just need to remind ourselves, for something to be real, it needs to be greater than 0, right? Greater or equal to 0. But for it to be unequal, it needs to just be greater than 0. So here the discriminant should just be greater than 0. That's what we're going to be doing to the discriminant, making it greater than 0 and solving for the values of m. The second one, for it to be real, it means the discriminant needs to be greater than 0. But for it to be equal means not just greater than 0, but actually equal to the 0. So here I'm going to make the discriminant actually equal to 0. And for non-real, the discriminant has to be less than 0. So we're going to solve each of these inequalities. Well, some are inequalities, but the other one is an equation. And yeah, from there, we're going to see what the values of m is. So let's remind ourselves, our discriminant is negative, it's b squared minus 4ac. So now I'm saying that this discriminant for the first case has to be greater than 0. So let me substitute. My a is 1, my b is 4, and my c is the m. So I have 4 squared minus 4. My a is a 1 and my c is an m. So that's how my inequality looks, right? And then if I solve for that, I have 16 minus a 4m is greater than 0. I take my m to the other side. 16 is greater than a positive 4m. Divide by 4, divide by 4. And so this means 4 is greater than m. Or you could read this as m is less than the 4. And there we go. That is question A. And I hope you're noticing what's different between the questions that I was doing earlier and these questions. So the earlier questions were actually asking you to discuss. They gave you an equation and they wanted you to discuss what types of roots there are. These questions want you to find the values of m for which they already told you what types of roots they are. So you're going to first need to find what your discriminant needs to look like, and then you take that discriminant and you solve it. So that's question A. Let's do question B. So question B, I'm going to take the same discriminant, but now I'm making it equal to 0 because I want these roots to be equal and to be real. So if I substitute, it will be a 4 squared minus a 4, 1 with an m equal to 0. And you end up getting a 16 minus a 4m equal to 0. And if you take your 4 to the other side, it's a positive, divide by 4, divide by 4. So m is actually equal to 4. So the value of m that will ever make this equation to have real roots and equal roots is 4. Right? Then let's look at ones that will make it unequal. So unequal, the discriminant has to be, oh sorry, not unequal but non-real, has to be less than 0. So this is question C. And again, I'm plugging in the same values. This is a 1 for A and this is an M. And so, yeah, you just solve for that. 16 minus 4M is less than 0. You take this to the other side. You divide by 4, you divide by 4, and so, sorry, it's a 4. So 4 is less than M, or rather M is greater than 4. So that's the only M values, the ones greater than 4, that will always give me non-real roots. And there we go. I hope you're seeing the contrast between the prior questions and this question here. I'm gonna do another example on these types of questions, and we'll see how we go. Alright, so for this question, it specifically reads that we need the values of m for which these roots are going to be equal. So equal already implies that they're real, and yeah, it already implies that they're rational. So what I need to do is I need to establish what is my a and my b and my c value. So here I notice that I can actually factor out an x there, and if I factor out an x, should I factor out a positive x? Yeah, I factor out a positive x, and so inside of my bracket I will have a negative m to multiply, give me back to that, and I'll have a positive 2 inside with my plus 1 right there, all equal to 0. And why am I doing this? Just so I can clearly see what my b is, I can clearly see what my c is, and I can clearly see what my a is. So a is a 1, the b is a negative m plus 2, the c is a positive 1. And now that I have these guys, I can now find my discriminant. But remember, for equal, the discriminant has to be equal to 0. So I'm taking what my discriminant is, and I'm actually making it equal to 0. So let's substitute. It will be a negative m plus 2 squared minus 4, 1 for the c, and I'm making this equal to 0. The first one, you just square the m. It's an m squared. You square the 2 is a 4. You times them together and you times them by 2. You get a negative 2m. No, a negative 4m, sorry. Because if you times them together, that's a negative 2m. But if you times them by 2, it's a negative 4m. With a minus 4 is equal to 0. And you're just solving this simple, oh, actually it's going to be a quadratic equation. So these cancel. So m squared minus 4m is equal to 0. So factor out the m minus 4 is equal to 0. So actually the values are m should be equal to 0, or that m should be equal to a positive 4. So given these two values, whether m is equal to 0, it's going to give you real, rational and equal roots, or if m is equal to 4, it's going to give you real, rational and equal roots. So those are the values of m. And yeah, I hope this makes sense. Let's do 2 more examples, and these ones are when we are asked to show. So this one is not where they're asking for the values, but they're saying this is what the thing is. These are the roots. You just need to show that they are in fact true. So let's look at those examples. All right, so we're given this equation up here, which also has p's, so we can straight up see that our a is 1, our b is p, and our c is the p minus 1. Obviously, you would take this over, and the p minus 1 would collectively form our c. But what the question is asking is to show that the roots are rational for all rational values of p. So what do? We again need to understand that we need to solve the discriminant, right? So let's take our discriminant and solve for it. Substitute what the b is, which is p, and I'm squaring it. Substitute what the a is, which is a 1, what the c is, which is that binomial there. I square this guy, I get a p squared. Negative 4, that is timesing the p is a negative 4p. Negative 4 times a negative 1 is a positive 4. So you end up with this guy. And what you need to do is to factorize this guy. Factors of p that add, or rather factors of 4 that add to give you the middle term is p minus a 2 and a p minus 2, and you should notice that that bracket is the same, so it gives me this guy, and so my discriminant is equal to this guy. But how do I rationalize this? How do I put this into perspective? One thing we're noticing is that this guy is squared. So the fact that he's squared, it tells me that this is a perfect square. Right, you guys are used to perfect square being 25, but 25 you can actually write it as a 5 squared. So anytime I see something that has a square, it is in fact a perfect square. So the fact that it's squared there tells me it's a perfect square, right? And anything that is a perfect square tells me that actually it's rational. So again, perfect square tells me that it's rational. And remember, they're saying for all rational values of p. So here, as long as I'm coming to substitute rational numbers, then my answer will always come out as a rational roots. As long as that p is not an irrational number, like if, for example, if I put in a square root of 2 minus a 2, then that will change, because I mean that p value is an irrational number now. But as long as I'm substituting rational numbers, which are fractions that are integers divided by integers, remember, integer divided by an integer is a rational number. So as long as I come substitute those values for p, will always come out the discriminant being a perfect square, obviously because of the square there, but it will also come out as a rational root. So it tells me that the roots are in fact rational because of that square there, and obviously if it's rational, it means they're real as well, and whether they are equal or non-equal we can't actually tell here. We would actually need to find the actual values of p that are going to give me equal or non-equal roots. I hope that makes sense, guys. I hope you're seeing what is the logic here. I do want to look at one, maybe two more examples on these, because yeah, there's a variety of questions you can get for these, but let's look at maybe one or two, or maybe just one more example, and let's see how we're gonna rationalize that or solve it. All right, so we have question number 9 in front of us. This will be the final question, and I love this question because instead we are given the equation. This guy is the equation right underneath there after they've substituted into the quadratic formula. So these are the roots that we should be coming. If we knew the values of k, we'll just substitute there and find the actual roots, right? Of the numbers of the roots. But instead, we're not asked to do that. We are actually asked to find the values of k where the roots are going to be equal, non-real, and undefined. But equal, what do I remember? The discriminant needs to be equal to 0. For non-real, the discriminant needs to be less than 0. For undefined, I'll speak more about that. Undefined, remember, it's anything divided by 0. So we'll speak about that once we get there. But let's start with question A and question B. So in this case, the discriminant is given. It's this guy underneath the root. So I could just take him the way he looks. And remember, if it's equal, then these roots, or rather the discriminant needs to be equal to 0. So discriminant needs to be equal to 0 for equal roots. And they just solve for k. So this is a difference of 2 squares. So solve it like a difference of 2 squares. 10, square root the first guy, 10, 10. Square root the second guy is a 2k, a 2k. One is positive, one is negative. So the 10k plus 2k, the 10 plus 2k is equal to 0. The other 10 minus 2k is equal to the 0. So here, take it over, is a positive 2k, divide by 2, divide by 2. And so k is a 5. And for this one, 10 is equal to negative 2k. Divide by negative 2, divide by negative 2k is equal to negative 5. So what does this mean? It means if I go and substitute negative 5 or positive 5 for k there, then these roots are going to be equal. They're going to be giving me one root actually that is the same number, or two roots that is the same number. Then B is therefore asking, when will the roots be non-real? So for non-real, my discriminant needs to be less than 0. So I'm solving the same equation, right? But now it has to read less than 0. And how do you go about solving that? You just solve this inequality again. It does need you to factorize. So we're just going to use this guy minus 2k, or 1 is plus 2k, less than 0. So my critical values are, these are my critical values actually, where k is equal to negative 5 and where k is equal to a positive 5. So these are my critical values, but ultimately I need to still draw it on my inequality to see what is actually happening. So negative 5 is there, positive 5 is there. That equation there is a positive, or rather my a is a negative, so it means it's going down like that. It's a sad shape. I hope you're seeing what a I'm talking about. The a that is right there multiplying the k squared, that is our a. So it tells me it looks like this, and since this guy says less than 0, means I'm looking for the range down there, and I'm looking for the range down there. So k is less than negative 5 for that range, and k is greater than positive 5 for that range. So those are the values I was looking for. So I've done that part, and then the last question then says, what if it was undefined? What values of k would you be getting for undefined? So I go back to this guy. And undefined, remember, it's division by 0. So I'm saying this guy would be equal to 0, the denominator. And if it's equal to 0, then it means undefined. So I'm going to take the 2k and I'm going to make it equal to 0. And so I just divide by 2 on both sides. So k has to be 0 for these roots to be undefined. So that's the value of k. And there we go. We're done. Quite easy. And I hope you can see the variety of questions that could be tested for nature of roots. I hope you understand it. We started with the first types of questions, which are asking you to discuss. So we're actually solving for that discriminant. We're seeing what value it is, and we're saying something about those roots. Then we did the second part, which needed you to either show that it was non-real or show that it was equal roots, or do that part. And then the last part was when we're given the actual quadratic formula where they're substituted inside, and from that we have to find these different elements of it. Again, it's all talking about the roots. So in any, you'll notice that in none of the questions that we did we actually solve for the value of x. We didn't solve for the roots, we didn't solve for them. All we did was speak about them from our understanding of that discriminant value. So I hope this makes sense. I will see you on the other side. Bye.